Here we're given a triangle with side included angle and side known. In other words, they've given us SAS, one of the preconditions necessary to use the law of cosines. By the way, if we tried to use the law of sines, we'd be frustrated. We simply don't have 3 out of 4. If I try to use angle C and side C and angle A and side A, you can see that I am frustrated. I have 2 unknowns. If I try to use angle B and side B and angle A and side A, again, I'm frustrated. When given SAS, try as you might, you won't be able to use the law of sines. So SAS means law of cosines. We don't have much of a choice, do we? We've got to go after side A. So I know that this squared is equal to this squared plus this squared minus 2, this, that, cosine of that. So A squared is equal to B squared plus C squared minus 2BC cosine of A. If I start with side A, I'm going to end with angle A. So A squared, the unknown, is equal to, I can make my substitutions now, 9 squared plus 12 squared minus 2 times 9 times 12 times cosine of 25 degrees. Now, just in general, I know we're talking about one problem, one needle in the whole haystack, but take a look at how I set up a problem. I write my pertinent formula, and then I substitute into it. I feel like an alien could come down from outer space and say, yep, I understand it. I understand what Mr. Curran did. Some students I have seen, I'm not going to mention any names, give me a plate of spaghetti and they ask me to figure it out. And if the answer's wrong, I just go, I just don't know where you started. So always a good idea to get full credit for mathematical communication by writing the pertinent formula or theory or whatever, and then substitute into it so that everyone can understand what you did, and then we can all see why you got it right or where you went wrong. Now, if I had written an 11 there instead, maybe that's 1 point out of 10 that I get wrong. But if I just leave a jumble of spaghetti there, I might get almost all the points off, right? So think about that. So now I'm going to use my calculator to figure out what this is, and that gives me A squared is equal to this, I want to find out what A is, right? I could find out what A squared is, but who cares? A is going to be plus or minus 9 squared plus 12 squared minus 2 times 9 times 12 times cosine of 25 degrees. Make sure your calculator is in degree mode. And why don't I write plus or minus? Well, A is a distance. It's not going to be a negative distance. So I don't take the negative root. I just take what's called the principal root here. And I'm going to carry a few extra decimals, 5.4072. So there is my A distance right here. It's about 5.4072. Now I've got enough information to go after one of these angles. Note that angle C is across from 12, which indicates to me, you guessed it, it might be an obtuse angle. I want to stay away from obtuse angles with the law of sines. I'm going to switch over to law of sines because now I have enough to do 3 out of 4. So that allows me to focus my attention on angle B, because I see angle B is across from side B, and side B is smaller than side C. So there can only be one obtuse angle in a triangle. I know that angle B is acute, and so I can find it using the law of sines. Sine of angle B over B, which is 9, is equal to sine of 25 degrees over our 5.4072. It doesn't hurt to have this extra accuracy here. Now cross multiply and we'll get 5.4072 sine of B equals 9 sine 25. Now we want to isolate sine of B. So sine of B is equal to 9 sine 25 degrees over 5.4072, which implies that, I'm going to switch over here, that angle B will be the inverse sine of whatever mess that was, 9 sine of 25 degrees divided by 5.4072. So angle B is, please let this be acute, please let this be acute, is about 44.7 degrees. Notice I don't have all the accuracy there. And so if I go back to my picture here and I say, this here is 44.7 degrees, I know that the sum of the interior angles of the triangle are 180. So I can say that angle C is going to be 180 degrees minus, I was given 25, minus, I just found 44.7 degrees. So here, this angle C is going to be 110.3 degrees. Oh my goodness. Take a look there. This is 110.3 degrees. We would have had a mess on our hands. We would have gotten the wrong answer had we used the law of sines here, because it would have given us an acute answer and we wanted the obtuse triangle. I'm sorry, the obtuse angle.